welcome for day 2. We're going to continue solving equations, and we're also going to solve inequalities. So we have x plus 2, square root of x plus 2 plus 1 equals square root of 3 minus x. Now looking at this problem, there isn't anything that we can do. It looks like that we might be able to, right? Maybe we could subtract 1, but really that's the same thing, so that doesn't help us at all. So what we want to do here is we're going to want to square each side. So what we did before is we squared each side of the equation in order to get rid of the radical. Now on the right side it'll be nice for us, but on the left side we see that it's a little messy, or it could be a little messy. So let me do that work over here on the side. So remember, when we have a binomial like x plus 2 squared, we can think about that as a squared plus 2ab plus b squared. And so that's the same thing we can look at when we have x plus 2 plus 1, and that's raised to the square. That just means it's square root of x plus 2 plus 1 times square root of x plus 2 plus 1, okay? And then so we just notice that this is our a value and this is our b value. So like here, this is a and then this is b. So you can think about that with the pattern. Now if you have a difficult time with the pattern, let me just do the box method. So something we're used to. So let me do that. So I'm going to plug it in. So this is our square root of x plus 2, and then our plus 1, and then square root of x plus 2, and then our plus 1. So when we're multiplying the square root of x plus 2, notice that's just squared. So it's kind of like with our box method, right? If I was doing x plus 2 here, this would be x times x is x squared. So it's the same thing, right? It's just squared. Then we have this 1 times the square root of x plus 2, and then times 1 times the square root of x plus 2, and then 1 times 1 is 1. So let me do that here so you can see it. So this is 2x, and this is 2x, and 2 times 2 is 4. And so remember what we do with these numbers here. 2 plus 2 is 4x, right? We're just looking at the coefficients. So in this case, our coefficients here is just 1. Okay, so that's when we're going to add the like terms. So first of all, let's look at this first box. So square root of x plus 2 squared, I hope you see that that is just x plus 2, right? This squared cancels out that square root. Then here we have 2 of this x plus 2, so that's why it is 2 square root of x plus 2. Then we just have a plus 1. So I want to look back and look at the pattern here. So notice if I did a squared is just this squared. So that's just our x plus 2 without the square root. Then 2 times ab. So this is a times b. So it's just 1 times square root of x plus 2. And then we multiply it by that 2 that has to be there. So look, it's a 2 square root of x plus 2. The last thing is b squared, which is just 1. So if you like the pattern and you can work with the pattern in your head, that is very helpful in this case. But if you can't, you can always do this, the box method. So now let's go ahead and write this here, and let's continue solving this problem. So it's x plus 2 square root of x plus 2, and then plus 1. And then on the right side, the square takes care of that square root, so this is just 3 minus x. So now what we do is notice that we still have this radical here. So now we have to isolate this radical again. So let's move everything to the other side of the equation. So first, let me combine like terms here. It's up to you however you want to do it. But I see two constants right here, 2 plus 1. So let me simplify this. This is x, right? So dropping down the x, and 2 plus 1 is 3. And then we have this plus 2 square root of x plus 2 equals 3 minus x. Now to start to isolate this radical here, so our goal is to isolate this, is we're going to subtract x, subtract 3 from both sides. So subtract x to get rid of that, and then subtract 3 to get rid of that 3. So now we have 2 square root of x plus 2 equals 3 minus 3 is 0, and then negative 1x minus x, that is negative 2x. So now again, we're trying to isolate this radical. So let's divide by 2. So now we have the square root of x plus 2 equals negative 2x over 2 is a negative x. Now this is starting to look like what we've done before. So we have a radical isolated, and then what we want to do to get rid of it is we're going to square both sides. And so that squared takes care of the square root. And now we have x plus 2 equals negative x times negative x is an x squared. So now we have a quadratic, no more radicals. Remember, with quadratics, you set equal to 0 to solve. Now, if you get a linear equation like x minus 5 equals 3x minus 4, you have to solve, so that's linear, and then you solve for x, meaning you get x on one side and then the constant on the other. Okay, so just kind of the subtle differences between the two. Quadratic, you set equal to 0. Linear, you solve for x, so combine constants and combine the x's on opposite sides of the equal sign. So since this is a quadratic, let's subtract x, subtract 2. We set it equal to 0. So now this is 0 equals x squared minus x minus 2. Then this is factorable. So what multiplies to negative 2 that adds to negative 1? So that is negative 2 times a positive 1. Negative 2 times 1 is a negative 2, and negative 2 plus 1 is a negative 1. So therefore, this is x minus 2, x plus 1. So now we see that x equals 2 and x equals negative 1. Now we have to plug it into our original. So let me fix this a little bit. So let me clear this out. So now we're going to check it in this original equation. We have x equals 2, so let's plug it in. The square root of 2 plus 1, does that equal the square root of 3 minus 2? So square root of 2 plus 2 is square root of 4 plus 1. Does that equal 3 minus 2 is 1, square root of 1. Square root of 4 is 2 plus 1. Square root of 1 is 1, so 3 equal 1? No. So this is not a solution. So let's try x equals negative 1. So square root of negative 1 plus 2 plus 1, does that equal square root of 3 minus a negative 1? So don't forget that's a minus already, so we have to do a minus 1 there. So negative 1 plus 2 is the square root of 1 plus 1, and then 3 minus a minus 1 is a plus, so that's 4. So on the left side now, square root of 1 plus 1 is 1 plus 1. Square root of 4 is 2, or 2 equals 2. So therefore, our only solution is x equals negative 1. So these are like our level 3 type problems for Algebra 2. A little difficult. I think the hardest part is probably multiplying here, and it is a lot of steps, but I think it's doable. So try out number 7. It's very similar to the first example, and see if you can get the answer on this one. All right, here's the work if you tried it out. So I multiplied with the box method here just so you can see the work. If you can't do the mental math in your head, and that's okay. So we multiplied it, you would get x plus 6, and then you have 2 of the negative 2, x plus 6. And then so negative 4 square root of x plus 6 plus 4 equals x minus 2. Then we want to isolate this radical again, so subtract, I added 6 plus 4 and then we get that 10. Subtracted x, subtracted 10 on both sides. Then I would have negative 4 square root of x plus 6 equals negative 12 divided by negative 4. And then you continue on. I continued on over here. So then I squared both sides. So I got x plus 6 equals 9. And then subtract 6 from both sides, and x equals 3. And then I did the check. And so then 1 equals 1, and so it works.